One of the more recent projects I've been involved with EDT has been finite element analysis. And finite element analysis is the analytics of how structures and equipment fail using computer technologies. It's a means of breaking down large structures into little elements, and each one of those little elements is the finite element of the finite element design. And those elements, their borders and how they interact with each other can be mathematically defined. In doing that and setting the borders and constraints up properly, we can analyze how those loads affect structures and pieces of equipment. I had a finite element case where I was asked to analyze a crane at the Bonneville Dam in Oregon. The Bonneville Dam is on the Columbia River. It has a couple of locks which allow ships to travel upstream, and it has a crane to be able to put out what were called stop logs. Now, stop logs were big steel caissons that were lowered on either side of the dock so they could service the dock, the lock mechanism. And the crane, of course, had to pick those up. Over the years, the crane developed fractures in the welds. So we used finite element analysis to analyze how the various connections between each one of the elements that would make up a lattice crane were behaving, and that's how we could see where the fractures were occurring and able to give me an idea of why the fractures occurred. And it ended up being a bit of overloading from both wind and different crane angles.